Okay, our next lesson is on slope, distance, and midpoint, as it is seen in the ACT. Now, the first concept I want to talk to you about is slope, and it is very important that you have your formulas memorized for this test. So you either need to know that slope is y2 minus y1 over x2 minus x1, or it's the change in y over the change in x, or it's rise over run. If you know all three of those, it'll really make your life easy. So let's look at our first example. And I've given you the formula, but again, it's your responsibility to know it for the test. What is the slope between 2 points 3, 4 and 5, 8? So if you go ahead and you just know the formula, you're going to go ahead and set it up as 8 minus 4 over 5 minus 3, which is 4 over 2, which of course the ACT is going to want you to reduce that to a 2. 2 over 1 is also equivalent, it's just not how they're going to write their answer. Now, if you were stumped and you didn't have a program or couldn't remember formulas or you were just having a really bad day, my next suggestion to you is to go ahead and graph this out. Draw yourself a teeny tiny coordinate plane, plot the points, and you probably would remember that slope is rise over run, and you could probably figure out the answer just by counting. Does that take longer in most cases? Yeah, but it's better than getting it wrong. Again, we're going to find slope here. I'm just going to assume you know the formula. So we have negative 1 minus another negative 1 over negative 3 minus 2. Now this is kind of an interesting case. Our numerator becomes a 0 divided by negative 5, and if you tried typing that in your calculator, you'd actually get a 0. So in this case, the slope between these 2 points is 0. Now if 0 showed up in our denominator instead of our numerator, you cannot divide by 0. Your calculator would give you an error. That's because that is an undefined slope. So make sure you know the difference between those two. Now this next question is a story problem. However, the key word right here is slope. And if you look at the very end of the problem, it says, what is the slope of the planned ramp? They just want you to calculate slope. Now, reading all the rest of this problem, they did some fancy stuff with a blueprint and they superimposed it onto a coordinate plane, and they gave you 2 points. So you're going to have to figure out slope. So 2 minus a negative 3 over 12 minus 1, which gives us, let's see, 2 minus negative 3 is positive 5 over 11, and that is our answer. Now, look at the answer choices and look at how sneaky the ACT is going to be. If you had slope formula upside down and you put 11 over 5, that was an answer choice. If for some reason you just had a crazy time with your negative numbers and you thought 2 minus a negative 3 was a negative 1, that answer is going to be there. If you thought 2 minus negative 3 was a negative 5, or you inverted the numbers somehow, that answer is going to be there. So every single mistake that you can think of that's common, they put there for a reason. They want to try to catch you in that mistake. So don't fall for it. Slope-intercept form of a line is y equals mx plus b. And if you remember from algebra, let me move this out of the way. M represents the slope, and b represents the y-intercept. So if I just give you 2x plus y equals 6, and the question is, what is the slope? Normally it's really easy to look if it's in slope-intercept form. This guy's not quite in slope-intercept form. We need to go ahead and subtract the 2x over and get y equals negative 2x plus 6. And now you can tell me that the slope is a negative 2. A lot of children tell me at first glance that the slope is positive 2, which of course is wrong. We got to be careful. Number 5 is very similar, except now we're really not in the right form. So the first thing I need to do is subtract the 3x and the 4 over. So I get negative 2y. I could have also done another thing, and we'll talk about that in a second. Equals negative 3x minus 4. And then go ahead and divide everybody by a negative 2. But don't actually divide everybody by a negative 2, because all they want to know is slope. So the negatives would cancel out, and it turns out our slope is going to be 3/2. So I don't really care to finish that problem because all they wanted to know was the slope. Now, I'm hoping someone in this room maybe noticed that we could have added the 2y over instead. So 3x plus 4 equals 2y. It's just one of those things that makes your life a little bit easier. And then when you go ahead and divide by 2, you don't have to worry about the double negatives. You don't have to worry about that extra step. The slope is still 3/2. Doesn't matter which way you did it. But something to think about. How to isolate variables in a more efficient manner. Okay, parallel lines have the same slope. That's because they're going up and over at the same rate. That's why they're parallel, and they'll never cross. Perpendicular lines, however, have what we call opposite reciprocal slopes. Now, opposite meaning one's positive and one's negative. Reciprocal meaning the fraction will flip. So as an example, 2/3 versus 3/2. And that's how we're going to tell if they're perpendicular or parallel or possibly neither. So in this first question, what's the slope of any line that is parallel to that? So the original slope is 1/3. I can tell that because it's the coefficient of the x and we're in the right form. Now the parallel slope, I gotta think back. Parallel means that we have the same slope, so his slope is also going to be 1/3. Now example 7, what is the slope of the line perpendicular to this? Well, the original slope I can tell easily is a -2, but this time they want my perpendicular slope. So I need to think about the opposite reciprocal of -2. Well, opposite would be, instead of being negative, it'd be positive, and then the reciprocal of 2 would be 1/2. So the perpendicular slope would be positive 1/2. Example 8, what is the slope of the line parallel to that guy? Well, it will be an easy question once we know slope. Unfortunately, I can't see slope too easily. So I'm going to go ahead and I'm going to subtract the 3x. And then we're going to divide everybody by -4, and I'm going to kind of cheat again. I'm not actually going to finish the problem. Turns out the original slope was 3/4. And since they want parallel slope, it's the same slope as before, so it's 3/4. Now the next question, it's wrong on my presentation here. Hopefully I fixed it on your paper already. I actually want you to find the slope that is perpendicular to this, not parallel, because that's boring to find another parallel one. So again, we got to get it in the right form first. So we're going to subtract the 6x over. So 5y equals -6x plus 9. And then divide everybody by a 5. And again, I'm going to kind of cheat. Not actually going to do it. I get a slope for the original problem of -6/5. And if I want perpendicular to -6/5, that's going to give me a positive 5/6. Alright, moving on. Distance on a number line. So a number line you can really just count, but it's good to know formulas sometimes. It's just the absolute value of the difference between the two values. So absolute value, because distance is always positive. The absolute value of -4 to 12. Well, that's 16 units apart, and if I take the absolute value, it's 16. Excuse me. The next question talks about distance on the coordinate plane. Well, here we have x and y components, so you have to use the distance formula, another formula that you need to know. Now, distance formula is really just Pythagorean theorem, and I know you all know Pythagorean theorem. I'm going to show you how you can draw it out if you ever forget distance formula. So -1, -3 is down here, and then 2, oops, pretend, is up here, and they want to know the distance, oh geez, the distance between these 2 points. Oh my goodness, it is so hard to draw on this. Well, what your friend Pythagoras would do is he would draw a little triangle in. And it was a right triangle. I know mine doesn't look like one. But he would say that the horizontal distance between these two guys went from a -1 to a 2, so that was 3 units. And then the vertical distance went from a -3 up to a 2, so that's 5 units. So to find the distance, he would simply do Pythagorean theorem, which would say square root of 3 squared plus 5 squared. Well, that's exactly what distance formula would have you do. Take the difference in the x's, or the change in the x's, and square it. The change in the y, square it, and then square root the answer to find the hypotenuse. So our answer here would be square root of 9 plus 25, which is the square root of 34. Alright, moving on. So what is the distance between these 2 points? I'm going to go off the assumption that you have your formulas memorized. If not, you're going to have to draw this out. But I kind of cheat when I do distance formula. I say when I go from a 2 to a 5, that's 3 units. And depending on which way you subtracted, you might have a -3. But I know that because I'm going to square it, it's always going to be positive. So I never include negatives on distance formula. I always make them positive. So 3 squared, and then -5 to -3 is 2 units apart. Again, I'm ignoring the fact that it could be -2 depending on how you subtract it. I'm going to go ahead and simplify this. We get 9 plus 4, which is the square root of 13. Now, example 12 is actually a trick question. It's a lot easier than it looks. What's the horizontal distance between the 2 points? Most children will go and find actual distance, which is distance formula, but they didn't want the actual distance. They just want the horizontal distance. So the horizontal distance would be the distance between the x coordinates. So 3 to 7 is 4 units apart. We're done. All right, the next concept is called midpoint. If you're on a number line, you only have one component, so you're just going to add the two values together and then divide that by 2. You're averaging them. So what is the midpoint between -2 and 10? Well, I would add them together, and then I'm going to divide them by 2. So -2 plus 10 is 8 divided by 2, which is 4. Very easy to draw these out, but just as easy to know the formula. Example 14. On a number line, the midpoint between 5 and some other value is -1. What's the other value? This is actually a trickier question. I am going to draw it out. The midpoint between 5 and -1. The midpoint between 5 and some other value is -1. Excuse me. So here's 5, and here's -1, and he's actually the midpoint. So if here's one endpoint, the other endpoint's like way down here. So you got to figure out how many units separate the midpoint from the other endpoint. So -1 to 5 is really 6 units. So if I take it down another 6 units, let's see, -1 take away another 6 units, that actually brings me to -7, and that is your answer. You could have done a more algebraic approach, but sometimes drawing it out really is more simple. Now, if you're on a coordinate plane and you have a line segment, that means you have x and y components, so you're going to have to add the x's and divide by 2, and do the same thing for the y's. So for my x's, I have 2 plus -4. We're going to cut that in half. And then for my y's, I have -5 plus a -1, and we're going to cut that in half. Whoops. So we have -2 divided by 2, and then -6 divided by 2. This is an ordered pair. And when I reduce it, I get -1, -3. Okay, and then our next and final example, it's a little trickier because now they're giving us some information that maybe isn't exactly what we thought. They're going to give us one endpoint, and then they're going to give us the midpoint, and they want us to find out the other endpoint. Now you could easily do this algebraically. You could also plug and chug, or you could do my favorite technique, draw it out. You've seen my graphs. They're not pretty, and that's okay. So here's 4, 3 up here. And then here's 1, 1. Now if I read carefully, it says 4, 3 is the endpoint and 1, 1 is the midpoint. So if I kind of think about extending, this line segment down, the other endpoint's going to be somewhere down here. And I don't know the exact location, but let's look at all my answer choices. Only one of these answer choices actually makes sense for where I drew it in that third quadrant. It would have to have a -x and a -y component, and this is the only one that actually fits the bill. So I'm done. If you don't believe me, go ahead and check it out and see if that does work for the midpoint of 1, 1, but it works. So that's your lesson on slope, distance, and midpoint.